Okay, so this is integration of hyperbolic functions. And basically, if we start with it, we know that the derivative of ln mod x is 1 over x. And we know that the derivative of ln 2x plus 1 is the dude, which is the derivative over 2x plus 1, or even a quadratic function ln of x squared minus x plus 2 is the derivative of the one over the other. So that obviously means that if we work backwards, it's pretty easy. The integral of 1 over x is ln mod x. By the way, mod x means absolute value of x. 2 over 2x plus 1 would clearly be ln 2x plus 1, and that is ln mod x squared minus x plus 2 plus c. Okay, so this is hell of a easy. If we've got something in this thing, we look and we see if we've got exactly the derivative on the top, then it is easy enough to do. Okay, everything else is linear, and we can do it by inspection. Okay, so let's just quickly have a look. This is 1 over 4x. So this is clearly by inspection. We can even go a quarter ln mod x. Okay, so we should be quick and we should be good at that. Okay, here 2x squared minus 9 is quadratic. We have a look here. We can see that that is the derivative. So there's no issue. That would be no need to do anything. Ln mod 2x squared minus 9 plus c. Okay. The next one is linear. So I know I want to have that derivative below. So this is going to be 6 over 3 ln mod 3x minus 2. Okay, so there it is. 6 over 3, which is 2 ln mod 3x minus 2 plus c. All right. And then we get to some trig ones where we've got cot x, and cot x is cos over sine, right? And sine's derivative is cos. So basically, sine's derivative is on the top. So the dude is actually on the top. So I could go, cool, this means that it's ln mod sine x plus c. All right, this is all new to the syllabus, and there's nothing too complicated about it, so don't read too much into it. The chances are the derivative is going to be on the top, or else it's going to be linear. So if we look at tan x, the integral of tan x is sine over cos. Cos's derivative is negative sine. So I just put that negative in and then compensate with that negative. So it's negative ln cos x plus c. Okay, as I say, it does not get complicated. We've got sine x plus cos x. It looks like it's complicated, but the derivative of sine x plus cos x, the derivative of sine x is cos x, and the derivative of cos x is negative sine x. So there it is. That at the top is the dude. So therefore, it's the ln of mod sine x plus cos x plus c. Okay, something like this, exactly the same thing. E to the x plus e to the minus x. E to the x, the derivative is e to the x, and e to the minus x is minus e to the minus x. So basically, I'm going to do exactly the same thing. Okay, so these are nice and easy. If you do get asked this, you can sort of thank your lucky stars. Okay. Okay, if they ask us now to find the integral of ln x, this we would do by partial integration, okay? This could also be 2 ln x or anything like that. By integration by parts, we would go 1 times by ln x. But in this case now, we want to let our f equal ln x, okay? So that our derivative is 1 over x. Our g dash we're letting equal 1. So g is equal to x. Okay, following the formula, I know that I'm going to multiply these two together minus the integral of these two. So there it is. The integral of 1 dx is x, and that's the answer. There's nothing to it. Okay. Watch out for dude type questions here. In other words, if it looks quite complicated, generally, guys and girls, if it looks complicated, I promise you it's probably going to end up being a derivative next to it. Okay. Here we've got ln x to the half. So that's the power function. What is the derivative of ln x? Is 1 over x. So basically, I've got a dude. So actually, all I do is integrate the bracket. Integrate the bracket means add 1. So that's 3 over 2. So it's 2 over 3 ln x 3 over 2. Look out for the dude type questions. Okay. All right. So what you might have to do is we might need to break this up into partial fractions. Okay. So 1 over, this is a nice easy one, 1 over x times x minus 5. Please make sure you know how to do this. So you would break it up into a over x plus b over x minus 5. You should have done this in one of the other lectures. So this is a x minus 5 plus b x equals 1. And you can solve for a and you can solve for b. Okay. So what you've got then is you've got what this is, and they're going to then hence ask you to find the integral. So we've got minus 1 over 5x plus 1 over 5x minus 5. Both of them have got an x to the 1, a linear at the bottom, which means that this is pretty easy to find the integral of it. This is going to be minus 1/5 ln x plus 1/5 ln x minus 5 plus c. So really, these are quite simple and quite a lot of marks. Okay, I want to show you, this shouldn't be here, but I want to show you what last year's question was. Okay, so this is a little bit more difficult, and there are a lot of marks attached to it. Look at that. That was 10 marks last year, and then 6 marks straight after that. Okay, so the 10 marks is obviously to break this into partial fractions, which is a lot of work here. It's a cubic. So you need to factorize the cubic. I think most of you hopefully just do it in your head. Otherwise, you're probably using your calculator. Okay, so what do? We break it up. I'm going to separate it into a over x minus 1 plus b over x plus 2 plus c over x plus 2 all squared. Just be careful when you've got a repeat factor here. Okay, so you've got a, your b, your c, and then we're going to cross multiply. And at x equals 1, I know my a is 1, my c is 5, and my b comes out to be 2. So this is what you were left with, and that was the broken up into partial fractions. So this was your 10 marks. Okay, hence or otherwise determine this dx, which is that. Okay, so what have we got? We've got this one dx. All right, so this part over here is obviously a straightforward linear, so that's ln mod x minus 1 plus 2 times by a nice linear ln x plus 2. And this one over here isn't, so you don't try and make up something and make it x plus 2 squared. This is a nice little linear dude question. I'm not dude, but you're going to bring this up, so it's x plus 2 to the minus 2. So I've got 5 over minus 2 plus 1 is minus 1. So that's x plus 2 to the minus 1 plus c. So it's a nice, easy question for 6 marks. Obviously, that would be minus 5 over x plus 2, but this would give you the full 6 marks. Okay. Now, if that was the question, the one question 10 and 6, and then this was the very next question was in last year's paper was for 8 and then for 6 marks. Okay, so the first question said this: determine x times e to the 2x dx. So there it is. I have done it all in one go just to show you. So this is quite clearly not that this is 2 functions multiplied together. So you needed to recognize to integrate it by parts. So if f of x equals x, f dash equals 1, e to the 2x, and this is linear, so it's a half e to the 2x. This is not linear because that's a function x times by e to the 2x. Okay. So now I'm just going to follow the rules and multiply these two together times by these two together, the integral of, and that is a nice linear. So e to the 2x becomes 1 over 4 e to the 2x plus c. 8 marks. Try it and see if you get the same thing. All right. Then we get to the next one. All right. And that was for 6 marks. Okay. So cosec squared x cot squared x dx. Now that looks complicated because you're thinking, what do I do? You might have spent some time changing cosec squared into 1 over sine squared, or cot into cos over sine, and see what you end up with. The problem is you're going to be left with a squared and then a to the power of 4 if you change it to sines and coses. Which I don't know where you would go from there. So if I was you, what I'd like you to do now is pause this video and give it a go. But obviously then if you've now switched back on, I'll show you what actually I think is the quickest possible way. I'm not sure what they would have done in the memo. All right, so if you have a look at it, as I say, if things look complicated, and especially with trig, the chances are you can probably find a dude somewhere along the line, right? Because you've got functions and you've got derivatives. Remember, the derivative of something is your dude. So if I've got powers, chances are I can turn one of them into a power function and then the other one might be the dude. So if you have a look at it here, this actually cot x, its derivative is cosec squared x, or negative, but that doesn't really matter. So if you make cot x your power function, so what I've done is I put it cot x to the power of 2. Then next to it is cosec squared x. I put in a negative and then compensated with another negative. Then actually, what is that? That it's its dude is next to it. And so all I do is integrate the bracket, and I've got minus a third cot to the 3x plus c. So I think super difficult, but actually pretty easy if you don't panic with it. But I'm telling you now, you will most likely be able to find a dude scenario. So you don't panic with this sort of thing. Have a look at your table and make one of them the power function and the other one the derivative. And if that doesn't work, then swap it around and make the other one the power function and the other one and see if it is the derivative. Okay.